All right, guys, here we go with our last question on the summer 21 question paper 6 1. And this is our coordinated sciences 0654. Now, it wouldn't be a paper without a physics question on springs and when we have to measure stuff. So I'm going to do this super quick because this is a question which I think really just involves using your ruler, using your calculator, and following all of the instructions that you are given in the questions, and that's it. Okay, so let's go for it. So we have a student using a spring to measure the mass intensity of a stone. We have got a full size diagram, and we have to measure L0. I've done so using my ruler, remembering to measure to 1 millimeter. Okay, and expressing as 5.3. Obviously, my answer is slightly different to the mark scheme, but that's fine because there's a scaling error. Okay, and you'll notice that all of my values, for example, the E value, which involves subtracting my measured value from 13.7, 3.4 compared to 8.2, I'd still get the marks. And similarly, my EA, which is taking my L0 value from this here, 8.9 versus 8.7. You notice here, E is correct from the candidate's values, okay? So notice, really all we're doing is a bit of use of our ruler, okay, a bit of ruler work. Okay. We're then going to take our values and we're going to use them to calculate the mass of stone. And we do so simply by multiplying 200 by EA and dividing by E, and we end up with a value of 211.9. Again, it's different to the mark scheme, but that's fine. The bit we do have to pay attention to is changing the answer to 3 significant figures. This is something that students often forget to do, and it's an easy mark to get as well. All we need to do is remember our rules on significant figures and go from there. Now, what I like to do is write it once in multiple significant figures, in this case 4, and then simplify down to 3. And that way, it shows that I'm thinking about the problem and thinking about the instructions given in it. Okay, so we've got 2 on 2. And notice that even though my initial value was different, 211.9 to this huge number here, my final answer is going to be the same. So I'm going to get both marks there as well. Okay, last little bits here really, we're already over the hump. Okay, we're then going to repeat the experiment. We're going to put the stone in a beaker of water. And what that's going to do is going to reduce the length of the spring because the upthrust of the water on the stone is going to require a lower tension and therefore a lower length of the spring. You notice that here in our value, the new value of the length, 10.7. Again, we're going to calculate the extension of the spring and they've given us the equation. All we do is we take our LW and we take our L0, which we measured way back when at the beginning of the paper, and we get 5.4. Notice again, I've got a 5.2 in the answers. We're going to use those now to calculate the density of the stone. We just give the equation, use the equation that we're given. Okay, 8.9 divided by 8.9 minus 5.4, and we have a value of 2.54. Now notice here, there's no requirements on significant figures here, but I've stuck with 3 just because that's what they've asked for previously. In the answers, they'll allow both 3 or even 2 significant figures. Okay, the last bits here really are the slightly harder, maybe ones that require a bit more thinking. Okay, the first thing it says is to avoid a line of sight error when measuring the length of the spring. Describe how we avoid this. Well, the way that we would do this is we would literally move our heads. If you could see me right now, I'm moving my head up and down in line with the ruler so that I can measure the length of the spring more accurately. What we don't want to be doing is viewing it at an angle. So what I've said is that you make sure your eye is level with the scale, not viewing it from above or below. Okay, and that's kind of one of those points down there. If you notice in the mark scheme, they give you a few point more here. Really, this is what I'm saying here, view perpendicularly to scale, but I'm putting it in language I think which is hopefully a little bit easier to understand. But I mean, there's some very simple things here. Make sure the ruler is close to the spring. And then also, this is the classic one, use a fiducial aid. Now, some of you may not know what a fiducial aid is. What this is essentially a stick, a pointer, something attached to the bottom of the spring, which will stick out and allow us to see the reading more clearly. Okay, now you can always tell if students have been reading mark schemes because they like to chuck out fiducial aids. The fiducial aid, I reckon I could ask many of my colleagues and they wouldn't know what it is. What it is something which is going to allow you to see things a little bit more clearly, as I say, like a pointer. Okay. All right, we then have a question about reliability. Reliability is always linked to repeating, okay? If we do an experiment, we never would normally do it once, okay? We would do it multiple times, and that would then allow us to get a confirmation and make sure that our data is reliable, okay? So if you're ever asked about reliability, I'd say 9 times out of 10, maybe even 99 out of 100, you're being expected to talk about repeating experiments and take an average. You notice they want both of those points in the mark scheme, not just repeat, not just average, but repeat and average. Last bit, and I think this is a freebie, the student decides to check their value for the density by using the mass calculated in M and measuring the volume of the stone. Suggest a piece of our apparatus that he could use to measure the volume of the stone. Well, here what you're really talking about is what would you use to do the displacement method, and you may know about this one. It's where you have a volume of water, you place the stone in the water, and you take the increase in the volume, and that will be the volume of the stone. And the piece of apparatus there is a measuring cylinder. Speaking from experience, a few students like to say a beaker. Beakers would not be suitable for this, mainly because the graduations, the divisions on a beaker are not fine enough for us to read. If you notice on a beaker, you'll have maybe a 0 to 50 to 100, 150, maybe even a 0 to 25 to 50, but not much more precise than that. Okay, a measuring cylinder will measure milliliters, and therefore it's a more precise piece of kit. Okay, there we go. What a nice question. I really hope this one comes up in the exam, because I think I would have a lot of confidence in people getting 8s, 9s and 10s for this one. If you've got any questions or you're unsure, please let me know, and I'm happy to help in any way I can. Thanks for watching.